This is a tutorial on how to solve systems of linear equations graphically. Now, what it means to solve a linear system is to take more than one linear equation, and for us, we're mainly going to work with two equations, and you want to see if they coincide or intersect at any point. That specific point of intersection will be the solution. Now let's take a look at a few examples so you get a better idea of how this works. So let's start off with example 1. So here we have a system of two linear equations. We have y equals x plus 7 and y equals negative x plus 3. Now if we wanted to solve this system, one way we could do it is to graph both the equations onto the same coordinate plane and see if they intersect at any point. So let's do that. Let's first graph our first function. So y equals x plus 7, so we'll have a y-intercept at 7 and a slope of 1. So there's our first equation. Now let's get our second equation on there. So we have y equals negative x plus 3. So we'll have a y-intercept at 3 and then a slope of negative 1. So we'll have an equation that looks like that on the graph. So now, as you can see, we have our system graphed on the same coordinate plane. So we have both the equations, and it looks like that the two intersect right here. Now the solution would be the coordinates to this point. So it looks like the x value would be negative 2, and the y value would be 5. So for this particular system of linear equations, the solution would be where x equals negative 2 and y equals 5. Now we can double check our solution by taking the x and y value and plugging it into our system and make sure the math checks out. So let's do that real quick. So for our first equation, we have y equals x plus 7. Well, y for us should be 5, and then equals our x value, which is negative 2, and then plus 7. Well, negative 2 plus 7 does equal 5. So that means that the first equation checks out. Now let's do the same thing to check the second equation. So again, we have y, which is 5, equals our negative x value. Well, our x value is negative 2, and then plus 3. Well, a negative 2 is a double negative, so that changes to be a positive 2. And then plus 3. Well, 2 plus 3 does equal the y value of 5. So that means that our second equation checks out with our solution as well. So for this system, we know for sure that the point negative 2, 5 is the solution. Now when you have a system of linear equations where there's one unique solution to the system, that is called an independent system. Now because we even had a solution overall, this system would be consistent since it has a solution. But specifically, when there's only one point where there's a solution, it would be a consistent and independent system. Now let's take a look at example 2. This time we have a different system. So our first equation is y equals 2x plus 1. Then our second equation is 2y minus 2 equals 4x. Well, since we already know our first equation, let's just graph that real quick. So we'll have a y-intercept at 1, and then with the slope of 2. So the line to our first equation will look like that. Now if you notice with our second equation, it's not in y-intercept form. So let's do that first so that we can graph it. So we have 2y minus 2 equals 4x. Now if we want to get this into slope-intercept form, we need to isolate the y. So let's first get rid of this negative 2 by adding 2 to both sides. So that leaves us with a 2y equals 4x plus 2. So now to further simplify, or to isolate our y, we need to divide the 2 to both sides. So that gives us y equaling 4 divided by 2, which leaves us with 2x, plus 2 divided by 2, which gives us 1. So here's our second equation, y equals 2x plus 1. Now if we graph that, it has a y-intercept at 1, and then a line with a slope of 2. So that will look like this. Now if you notice, our first equation and our second equation actually end up being the exact same line. Now when this occurs, the system is still consistent because there is a solution, but in fact there's an infinite amount of solutions. Since they're the same line, they're going to be intersecting at an infinite amount of points. Now this would also specifically be a dependent system. It's dependent because the equations involved in the system are actually the exact same. They produce the same exact line. So when something like this occurs, the system will be consistent and dependent. Now let's take a look at one more example. So here with example 3, we have another system of linear equations. We have y minus 4 equals 3x, and we also have y equals 3x minus 1. Well, let's get our first equation into slope-intercept form first. So we'll have y minus 4 equals 3x. Now we just need to isolate the y so we can get rid of this negative 4 by adding 4 to both sides. So our first equation is actually y equals 3x plus 4 when it's written in slope-intercept form. So let's graph that first equation. We'll have a y-intercept at 4, and then the line will have a slope of 3. So there's our first equation. Now let's graph the second equation in our system. So y equals 3x minus 1 will have a y-intercept at negative 1, and it will also have a line with a slope of 3. So that will look like this. Now if you notice, our 2 lines in this system have the same exact slope, which causes them to be parallel lines. Now since they are parallel lines, they will never touch or intersect at any point. Now because of this, the system would be inconsistent because there are no solutions. There can't be any solutions if they'll never intersect each other. Now another way we could see this is when you look at the 2 equations, they both have the same slope, which is 3, but they have different y-intercepts. So we know they're 2 distinct lines, but they have the same slope. So we could see that they're parallel lines, and they'll never intersect. And again, that would classify this system as being inconsistent, since there is no solution. And that's the end of this tutorial.